Hello and welcome to IEEE Soft Robotics podcast. Hello, Matt. Thanks so much for joining us in the podcast. I'd like to ask you first how you'd like to define yourself for the audience first time listening to you.
I think, what's the best way to describe myself? I'm an inventor, I'm an entrepreneur, I'm a former professor, I'm an outdoor enthusiast. So I kind of have my toes in all different, pools.
Mm-hmm. Yeah, that's interesting. So maybe before that, before going, because you have a lot of expertise and it's really interesting. But before that, I'm curious about your childhood. How was your childhood was
One
being
more time?
science? How was your childhood was being interested in science and technology? How it was, yeah.
So I think it was interesting being a kid. I was, in the Radio Shack days. I mean, my parents weren't tech people or engineers, so I had to figure out a lot of the things on my own.
Mm.
And it was always interesting to do projects because, in school there was the traditional science, but I would always be more interested in the building side of it and the making things. So I think, while I didn't get along with the traditional educational system every day, I was always tinkering as a kid, making things and making my goals a reality.
Yeah, yeah. Why didn't get along with traditional education? What's
I
something?
was an all-star slacker. It just sometimes social studies or the non-STEM things just didn't grip me the way that STEM did. And even in the sciences, I was more of a physics person than I was
Mm.
biology, geology, chemistry, those. So it really wasn't until like junior, senior year of high school when I got to take like physics that science class was awesome. Up until then, it was, and no disrespect, especially these days with what biologists and people who understand the body and the cells can do, but that just didn't captivate me. And
Mm-hmm.
so just if I wasn't interested,
Yeah,
I unfortunately couldn't motivate myself to go above and beyond in those classes.
yeah, yeah. That's interesting. Maybe first thing, what's the first robot you built? Do you remember what's
First
the first
robot
robot?
I built, the
Yeah.
first robot, I guess, I was about 10 or 11 when Lego Mindstorms came out.
Mm.
And so that was this new paradigm of I could actually code something up and make it move. And so, I spent my early teens playing with that. And then I think, the first robot I designed and built myself was junior year of high school for science fair. I built an autonomous robot. It was basically, I got this laptop that I strapped to a cart,
Yeah.
and I wrote up some code that would take one of our old GPSs from the car and read where it was, and had like an IR sensor to make sure it didn't hit anything, and used a Mindstorm. This was before Arduino, and I didn't know like BASIC or any of this stuff. So I was able to like hack a Mindstorms to talk to the computer, to spin the wheels. And so it was my first like, okay, I'm gonna code up a thing, use some logic. Wasn't my first programming, but it was definitely, I think, my first real mechatronic system, even
Mm.
though I didn't really know what that was at the time.
That's great. Yeah. I saw that you have a lot of interest. Now you are founded Flex Solutions since 7 years ago now, I think. Yeah.
Yep.
And yeah. And you were also professor and you also do YouTube videos also as fun and also tutorials. So how does this like pass for you when you're a PhD student and become professor? When you recognize that this is not what I want to do, can you tell us more about that? I think this is
Yeah,
interesting. Yeah.
I realized that very early on.
Mm.
For me, even grad school wasn't necessarily on my radar, but I met a professor when I was an undergrad who, towards my junior, senior year, was like, "You're a mechatronics person. You
Mm.
should go get an electrical engineering minor." I'm like, "What's mechatronics?" He's like, "Oh, it's computer, mechanical, electrical. It's kind of the intersection of all that." I'm like, "Oh, yeah, that's what I've always been doing." So then once I found these classes in college that made sense to what I was doing, that engaged me. And then, I was recruited to stay on for graduate school, and learned about how funding works in grad school, and that master's degrees really aren't funded the way PhDs were. So that was kind of like, well, in for a penny, in for a pound. If I'm going to stay for 2 years, might as well stay for 4 and get it for free. So I started with the whole graduate school thing. And, My first semester was the typical work for a professor, get research assistant, full tuition, full stipend, but you do what they tell you to do. And that wasn't me. And so then it was like, okay, well, if I transitioned into a teaching role. And so that's where my funding came from. And I then had this revelation of, well, if my funding is tied to teaching, then why do I need to do somebody else's research? Why can't I do what I want? Because I'm researching for free for all intents and purposes. I know people don't like to hear that, but do the math. And so then I found an advisor who at the time was building and running our technical entrepreneurship program at Lehigh University. Said, wait, so I got this teaching gig. Can I do my own project, start a company, build a thing, and will you advise me? And he's like, well, I'll advise you, but I'm not going to be your dad. I'm not going to be your boss. I'm not going to be, tell you what to do. You need to drive this. I will advise you through the process. And that's kind of what set this whole thing in motion. So can't say from day one, we'll say from day 90 of my graduate school experience, once I kind of started flipping it on its head, I realized that I was trying to build a company, build a piece of IP, and build a robot essentially, which later turned into Flex Solutions. And so to call it a means to an end is an insult to the process, because while I was teaching, I took it very seriously. I got very involved in pedagogy development, changing how, active collaborative learning, entrepreneurial minded learning, and the kind of what the faculty, I had the experience of, I just went through your program and know where I was lost. And I was, far more of the typical student, like, I got a C in college, like it happened. And so I also have the self-reflectance to look back on where I got derailed. And it's like those moments of, if somebody had just explained to me, the difference between a parameter and a variable, and like that a line is a model of a linear relationship, and that's, take the math side and relate it to the physics of it all, I would have had a lot more engagement, because I'm not a mathematician. And I laud my former colleagues who can just look at an equation and it makes sense to them. But that wasn't me, and frankly, that wasn't most of my peers. And that's where we got lost. And so, well, one could argue, well, only the best mathematicians should be engineers. Unfortunately, I think that STEM will continue to be as small as it is if we continue to take that approach to the education of the future STEM scientists. So really, that's kind of why being a professor, while it was interesting and it was cool to try out, I realized that it wasn't for me. But not to say that it wasn't a very interesting field, and what it affords for those who are into it, I think they love it, and good for them,
Yeah. I think this is really important part, especially because we had discussion about that last month about how you mentioned the PhD program and your experience. I think it's just still, not really deployed many programs. So how do you think we can deploy more something like entrepreneur PhD? So instead of spending 4 or 6 years in the same problem, and sometimes it's just, this issue here. And some people, I think 30 years ago, few people suggested to have PhD program 1 year only, not 3 years, 4 years, 5 years. So from your experiences, if you can tell us about how we can deploy entrepreneur PhD. So you have a problem and you can have it in the phases to start up or a company. Because I think that's something we don't speak about that. I think that's your experiences. If you can tell us how we can deploy that for the first step.
Well, I think it's a tough question, right? Because first of all, higher ed, for better or for worse, likes doing things the way they've always done it. And so I think there's a fundamental question that departments and programs have to address of, what do they see themselves as, and what are they looking for? And are they willing to adapt? And I think, my answer to that is look at the data. Look at how many of your graduates are staying in academia versus going to industry. And there's some great papers on there about, like, if creating a PhD student is the equivalent of giving birth, only one of your PhD students could ever replace you. and the average faculty member in their career graduates around 8 PhDs. We're not seeing exponential growth in higher ed in terms of number of faculty. So what are you going to do with all of these people? And the answer is they're going out into industry, they're getting jobs. So in my opinion, and what I think, the way I interpret the data as, I think it's important that we start looking at adding a mindset to the skill set that we're giving these students. So I think on the one hand, you have the traditional PhD program, but encouraging those students, like at Lehigh, we had a certificate in technical entrepreneurship where you could, as a mechanical engineering student in graduate school, take some graduate classes in intellectual property, in integrated product development, and things like that. So I think that, you know, the softer approach is stay where you're at, but add mindset. You know, there's been talks, at least in our program, of do we add technical writing to the graduate program? You know, things like that to really soft skills and skill set to complement mindset, because it's really those two things that are needed to succeed. And then I think the opposite extreme is what, you know, I created. I call it entrepreneurial minded dissertation. And I think the key to that is the separation of funding from intellectual pursuits, right? And I mean, I think that there are those NSF fellowships and things like that, but in a lot of ways, even those seem to be that the student ends up working for a faculty member, doing what the faculty member says. And I think, I don't know if it's necessarily designed that the project is driven by somebody else if the funds are tied to that student. And it's, I think, a lot like right now, you know, we're running an early seed stage pre-seed company, right? I'm dealing with angel investors. And what sets angel investors apart from institutional and venture capitalists is, for the most part, a lot of early stage angels invest in the person. They believe in me and what I'm going to do. And so while, you know, we talk about what the FlexBot and our company is going to grow to, the first money in was because they believed that funding me would be a benefit. And I think that that model is the same thing essentially as an entrepreneurial minded dissertation, where funding the student to follow their pursuits, because you're going to get so much more productivity out of somebody who's truly passionate about what they're doing and driving their destiny than somebody who's slugging through a day job. And there are checks and balances. You know, I'm a firm believer in general exams and boards for PhDs, and that you need a rigorous committee. And that whole concept of the check and the balance to ensure that this work is meeting the standard that's necessary. But if the definition of a PhD is the world's leading expert in your little sector of knowledge here, well, that definition could be applied to anything that somebody deep dives and pushes human understanding on. So I think from a department standpoint, teaching assistantships and all of that, at least from my understanding, and I just have a very siloed view from my upbringing, but thinking about, rather than TA-ships being either bridge funding for faculty between grants or being, shall we call it, signing bonuses for recruiting a graduate student to, great, you get the first semester free while you're shopping around to see what you're going to go do for your graduate career, thinking about using them as a tool for recruiting students. And I think it's a big opportunity to recruit non-traditional graduate students, where if your metrics for the TA-ships and really enabling that free thought is, okay, you need a 4.0 from a great school and great GREs and stuff, well, maybe there's the slackers like me who on the metrics didn't necessarily hit the boxes there. But if you let us free in our own little entrepreneurial minded worlds, you know, we're going to do good things. And it's a way I think that we can broaden our footprint.
I think that's a really excellent point. I think also Matt's related to the risk and ideas, and that's something we discuss a lot of time, that you in academia and publication, and sometimes if you have a risky idea, not incremental work, it reduces the chances to be reviewed or also get access funding. And I think that's something also, I think, yeah, still we can't go for just, yeah, as you do. you let your mind go and you have new ideas and just. So I think that's also something, yeah, still not impressed for
Yeah,
with.
and I think with risk and a lot of the metrics that we use to measure both undergrad, research and faculty, so both the graduate student and the faculty members work. Right now, it's a lot of dollars brought in, papers sent out, and students graduated. But I don't know if those metrics really measure what at least I believe to be most important, which is the impact of that work, right? And in my opinion, what's the point in publishing a paper if the only 4 people who read it were you, your grad student, and the 2 reviewers, right? Is that actually impactful? Or is it, thousands of views on a YouTube video describing your work that people can implement, or a textbook that you published based on your work, and it's now the standard in 5 schools? Well, that's not a peer-reviewed textbook in the traditional sense, but is it peer-reviewed that all these faculty members had all the McGraw-Hill catalog and they chose your book? So that must mean that they agree with what was written in that book? That sounds like your peers reviewed what you did to me. So I think it takes a willingness to step a little bit outside the comfort zone and see what happens. But
Yeah,
it is a change.
I agree with you. You said really excellent point. But I'm curious about the stepping from your comfort zone when you are a professor and now you're starting Flex Robotics. So this, I think this part was challenging for you. I don't know, when you start something, there's a stigma that you're leaving academia and you have new ideas like what you try to do now in Flex Robotics. So how this transition for you is a challenge, because I think many people are not willing to take this kind of a challenging, or it's not easy. So
No,
this
it's not.
energy, yeah. If you can tell us more details about that. You need something, you figure out that you want to start
Right.
like,
So I
yeah.
think my story really, Flex Solutions evolved out of my graduate work. So one
Mhm.
of the benefits of the way I did my PhD, where my funding was tied to teaching, I paid for the research through a company at the time was called Impossible Incorporated LLC. I always wanted a company called Impossible Incorporated. And I paid for the work through economic development grants because we were developing, at the time, the goal was I was a contractor. And every time I renovate a house for the guys I was working for, they'd forget to run a wire. And I was like, oh, this sucks. So I'm going to run a wire through walls without a mess. I'm going to invent a robot to do that. And then that's going to be my doctoral work. And one of the great benefits of, at least at Lehigh, based on the way that I set up the program, I own the patents out of it, not the university. And I think many people would be surprised. My general advice for everybody is read the directions. If you go on your school's technology transfer website and read the rules and regulations, they should be spelling out based on all these criteria. A lot of times it's who funded the work, right? Was the university paying for your mind to think about that? Well, then the university owns that. If the university was paying for your mind to do something else, well, and then you did this on the side, then you probably own that. But you should read the rules. And so, my time at higher ed was there's kind of the twofold. You have the research and the development. So when I was in academia, it was big research, little development, figuring out the technologies I would need to build a 1-inch diameter robot that could climb through a wall and drill through things and have all these sensors. So I had to develop a lot of technologies. And we have the patents to show it now, inventing the first true cylindrical joint, this ability to extend and rotate, and how do you implement that? And so, my time in higher ed was figuring out the how. And then it got to the point in which the technology had matured. And so it was time to commercialize. And so I kind of hit a decision point in my career in higher ed where I could continue on the trajectory I was on, which would be towards a much higher leadership role, running a much larger program, more on an administrative side, which would basically mean putting my building aside and put the robot aside. Or I could leave higher ed, leave a salary, and go out on my own and do it. And for me, it was an easy decision. But for many others, I know it's not as clear cut. But there's a famous late ski movie producer named Warren Miller, and he always had a saying that he'd end every year's movie with, "If you don't do it this year, you'll be another year older when you do." And it was the time for me. As my PhD advisor used to say, I have the union card. I have a PhD, so I can always go back to higher ed because I have the credential. But I need to go and do what I'm doing now. So it is very nerve-wracking to pack up your office and move it. I moved into a spare bedroom here in my house, and day one you wake up and no syllabus to write, but also here's how much money's in the bank account. We need to figure out the business side of this, the questions of, what are we doing? Who are we doing it for? And why do they care? Because I think, like so many of my colleagues, we had a great technology looking for a problem, which if you're familiar with the NSF's I-Core, that's its whole existence, is taking these great technologies that faculty members created and figuring out how to transfer them, I mean, in the NSF's mind, from I-Core to SBIR to business, but really how to find that golden product market fit for these technologies.
That's I think very interesting story. Yeah. So if you can tell us about the technology for Flex solution.
Yeah. So at the core of what we do, we're solving real world problems with cutting edge robotics, and taking that from nebulous down to what we've learned. There's all of these workers out there in fields like construction, inspection, heck, even ship maintenance, where they can see the problem. I got to tighten that fitting. I got to change that light bulb over a staircase, or I got to inspect inside this manhole cover. So they can see it, but they can't quite reach it. And even if they could, they're in these dangerous or confined and just inhospitable environments. So our solution to that is called the FlexBot. The FlexBot is a snake-like robot, 1 inch in diameter, that's made up of these rigid links. And every link has a camera and the ability to extend and rotate. And what this allows us to do is basically get into these spaces and then put a tool on the end, like a drill, a gripper, a sprayer, or even like thermal cameras, more advanced imaging. And so our initial, first thing we're looking at is, what if we took the equivalent of like a broom handle or a painter's pole and put 3 to 5 of these links on there? And so imagine, just kind of like a snake that you're holding by the tail, and you can steer it and get into those nooks and crannies. And all the cameras would give you the images. So if you need to map something, you can look at it. And then you could put a tool on the end. So let's say even something as simple as you dropped your keys down the storm drain. You could stand there for 30 minutes trying to hook it out with some bubble gum and a coat hanger, or you call the city, they show up with a FlexBot, grab it, pick it up, right? So that's one example. But really, even in like these manhole covers where you have all this high voltage systems, you got water on the ground. Water and electricity generally don't mix that well. So you don't want to jump in there. You can't just shove something because somebody decided to put a piece of equipment straight down. So you need a way to snake out and around. Well, that's where a FlexBot could come in. And so initially, we're really looking at this notion of assisting these skilled workers get where they need to get and do what they can't currently do. But then where we see the next steps going is, as we learn from these problems, we can actually add autonomy and our ability to expand and brace. Think about if you were in a chimney and you need to climb and you put your back against the wall and use your feet and your hands to slither up. Well, that's what our expansion allows, is that we can form like the S shape and brace just like your elbows against the wall, if you can envision that, and climb up. And so we could climb walls, pipes, ducts, and actually move through these spaces. And so that's kind of the next step. But what I think is one of our biggest assets is affordability. Right now, your average service robot costs about $50,000, which leaves them relegated to, basically warehouses, manufacturing plants, and good YouTube videos. So what we think and what we're able to do is drive that down by like more than 90%. So at less than 1/10 of the cost of these existing systems, you could get your hands on a FlexBot, which actually makes it feasible to put one of these in every work truck. And so we really see mass deployability as our biggest asset here, this notion of it's just a tool. And when we start small, it's a few thousand. But as we scale, because all we have to do is perfect this one link, and then we could sell you 3 links, 5 links. It's like Legos. You can attach them together. And so it basically becomes a mass producible power tool. And so we can drive that price point down and down and down towards even more people being able to get their hands on it. Similar to what we've seen in, home vacuum robots or even drones, right? Where you used to pay 50, 60 grand for something that wouldn't crash. And now you can get one for the holidays for your kids. It's insane.
Yeah, I like this point about affordability as well. But going back to limitation, maybe technological platform in terms of fabrication or the material itself and environment. If you can tell us about what could still really challenging for you, maybe in different aspects.
Yeah, I think there's two fields. I mean, I'm a mechatronics person. That's my specialty. So building the thing. And I used to talk to a lot of prospective students about, oh, I want to be a mechanical engineer. I want to be an electrical engineer. A lot of times they'd be like, I want to build robots. So I'm going to be a roboticist. And I had to be like, hold on, put the brakes on. Roboticists are really smart and really good mathematicians. And, they figure out where you are and how you path plan and perception and computer vision. But for the most part, they don't build the robot. If you want to build the robot, you want to be a mechatronics person. So, I'm more on the building side. So I think I can talk to from the construction side of the robot. For us, a big thing is how the motors, the gearboxes, the circuitry. We take a very affordable perspective to it, where kind of looking at what are going to be mass producible systems rather than what would be the easy way with an off-the-shelf solution that, maybe this motor and gearbox costs $500. Well, if I need a $500 gearbox in every link to make it work, I don't know if I'm ever going to be able to mass produce that. So I think for us, really, it was how do you come up with an architecture that, well, it still needs some refinement from our minimum viable prototype to thousands of units a month. It has the potential to be able to do that. Right? Like as good as SpaceX is at recycling, they're better than NASA, but they're not Ford, right? That's the difference. And so I think that's the hardware side. And hardware is hard. I think one of the things that people discount when you write code and you write code on a Dell laptop, well, you can pretty much guarantee, maybe we'll pick Apple because Apple's more robust or something, I don't know. But it's probably your code if it doesn't work, not their processor. Oh, when I'm doing this embedded development, is it my code? Is it my circuit? Is it both? Is it neither? So there's a lot of chasing your tail in development because there's a lot of variables, even in the simplest debugging. And then I think the other side of it is the software side, is the robotics. And I'd like to think that I and we as a company take a very practical view of the robotics industry. My newest joke is, have you seen a self-driving car? No, you haven't. You've seen, cars that can do okay. You've seen cars with engineers in them. We've come close, but we're not a self-driving car yet. And it's because it's a robotics problem, and it's a dang tough one. And then even there, can we drive in the snow? Can we do things like that? And there's a lot of society and technology of how do humans drive in a blizzard? We guess and check. How does society feel about robots guessing and checking? They're not okay with that, right? So there's things like that that we have to address. So as a company, we recognize that everybody and their cousin are trying to solve some of these huge robotics problems. Visual SLAM, how can we use cameras to figure out where we're at? And, machine learning based path planning and all of these sort of things that self-driving cars need, and quadrupedic robots and drones. So all these companies are working on those problems. Great, let them work on them. So if we can be very practical, and that's where this notion of 3 to 5 links on a pole operated by a human, kind of just getting shoved in a steerable scope as our minimum viable product, that's trying to distill the problem to close to where we think technology is today. And then as technology advances, be able to roll those functionalities in. You know, I joke that you have all these companies rolling the stuff in. Well, all the students who are working on it in a couple of years are going to publish their dissertations on how they made it work. So we can learn from that, you know? So
Yeah.
I think that, not to say, hey, please keep pushing the state of the art, but for a small startup like us, it would be very easy to get trapped into trying to bite off more than we can chew on the software and robotics development side.
That's also a great point. I think just ask you, Matt, about that's a question we have all the time. Why the translation, for example, when we do in research to industry, or as your example, is so challenging, so hard. How you figure out this idea could really transform it into something to be a product? I think there's something, yeah, maybe it was crystal clear for you, but sometimes it's just not clear whether, yeah,
Yeah,
how you
no,
feel
I
about that.
gotcha. Great question. This concept of translational research and the plans that they want you to turn into grants, and it it seems like just a checkbox. And while they aren't the silver bullet, I think iCore, and they take Steve Blank's lean startup approach, where they pretend that you don't have the technology, go learn
Mhm.
about problems. And that's what we as a company spend a lot of time doing, is talking to prospective customers. But prospective customer is not really the right word. We talk to people about what they struggle with in their day-to-day lives and the problems they have. The fact that we've invented the FlexBot really isn't important, especially at those initial conversations, because I don't want to taint their views. I want to learn what they struggle with and then use what I know to be, does this fit? But if you whisper in somebody's ear a solution, their conversation about their problem is instantly going to be tailored to what you have, regardless of if it's a good solution or not. So it's really important to go out and talk to people. So I think about, I remember a couple of my friends who were doing work on like lithium ion batteries. And it'd be interesting to go and talk to Boeing about why the 787 was struggling so much, and talk to Samsung about why their phones kept catching on fire, and learning about what those critical error. And so you can talk about it as if you are personifying that customer and sharing their pain, because that's what's necessary to be the fundamentals of translating that research. And even if it's 30 years out, to have that vision. And I'm a huge proponent, and I don't want there to be any misconceptions of this, of basic research. I think it's critical, and I think it's shameful how we're abandoning that, because it's a short-term savings that will have very long-term implications about the capabilities of society. I think everybody gets so caught up in what NASA does and what good is going to the moon. Well, you have a Tempur-Pedic mattress because of it. You know, it's not the fact that we went to the moon, which I still think is pretty cool. It's all of the basic research and things we learned that enabled our newer society that we can build on. So that's not to say that pie in the sky, putting a bunch of smart people and letting them do what they want to do, shouldn't happen. I think that you need a spectrum of people. And so for those who could be caught in the middle, but if you're going to be the world's greatest, right, there's only so many people who can just do whatever the heck they want. For the rest of us, we need to contextualize what we're doing and explain the impact of it. And really, I think, I'm part of a grant here in Pennsylvania for Pennsylvania Infrastructure Technology Alliance. It's through our Department of Community and Economic Development. And the goal is to connect researchers at Carnegie Mellon and Lehigh with industry. And then we need to go back to the state Congress and explain to them the impact that money, those tax dollars, are having. So even if they're funding basic research, it needs to be explainable to the people who are funding it what those dollars are doing. Because can you blame them for not wanting to just write a blank check without understanding what's going on? So I think that's, even if you don't necessarily translate it yourself, to be able to explain what the impact is of your work in a tangible way to John Q. Public, I think is critical, especially as we want to see a resurgence in funding for these sort of things.
That's also a very important point. Maybe a quick question here about how you can explain it to lay people, for example, to your public. This is challenging, I think. How you can manage to do that? If you can tell us about techniques, for example, to make
Yeah,
sure your impact is understandable.
I think a fundamental rule that I remember in my life is nobody cares about my technology. And that's
Mm,
really hard to grasp. And it took me a while. And if I had recordings of my pitches of this robot from the first time I pitched it to when I talk about it now, it's, I used to talk about the technology and what a
mm,
FlexBot is and these gearboxes and mechanisms and all of that. It's not the intricacies. It's what does it accomplish for somebody? What is the impact of that? Right, this thing can change a light bulb. Not it's got a couple brushless motors and some gearboxes and the buses at 48 volts and slip rings and gear. No, it's this thing that can steer and send video back and enable you to stay safe and not have to go in a manhole. And so it's what the impact of that work will be for them. And there's always been that if you really understand something, you can teach it to somebody, you can explain it, those mantras. I think that it's incredibly important to be able to explain at a high level what it is that you're doing, because if you're a PhD, it means you're the world's leading expert in what you do. So realistically, your graduate students, and your PhD advisor understand what you're talking about, but even your colleague down the street probably doesn't exactly understand because they're not the world's leading expert in what you're talking about. So can you bring it up a couple levels, right? Like when you teach an undergraduate class and you explain it one way, and then the next year you say, well, everything I told you was wrong. Here's how it works. And then the next year you say, everything I told you was wrong. Here's how it works. And then finally at the PhD level, you say, here's how it really works. Well, do the same thing with what you're doing and really boil it down to, and I guess have the self-confidence in realizing that you're not trivializing your work, but the more technical you explain it, the less awesome it sounds because it's right over people's heads, and people tune out when they feel like they're being talked down to, or they just don't understand. We live in the cell phone world and the Zoom world. They can do anything other than pay attention. So I
mm,
think it's really important to talk about the impact, to talk about what it could mean, to paint that picture of a vision statement and
mm,
a value proposition. I think is really big. You look at the value proposition canvas and the business model canvas, and they seem like tools that, oh, only businesses need a value proposition. Well, aren't you trying to get funded by a grant agency? Don't you need to describe to them the value? And if you're, a tenure track professor, well, who are your stakeholders? Well, we
mm.
got the publications, we got the grant agencies, all of this. So you need to describe value to all of these stakeholders. And so I really don't think they're that different. You just have to get rid of the word entrepreneur and just say, oh, okay, I'm one who takes risks and furthers things. And so then maybe I can use entrepreneurial tools in what I do.
That's great. So since you're really working very hard, I know that you're really working very hard in what you're doing, but maybe someone could say that why have to select the path that has maybe, yeah, just very challenging. Most of people select the easiest path for their life, and for you, you selected this path. And I'm curious about what could be you the learning lessons you have and why you think you have to still go this very challenging route and very hard. And what could be also learning from that learning process, still learning as humans as well. So.
Yeah. I mean, I think first of all, to thine own self be true.
Mm,
Everybody is different. And I know for me, it's taken a long time to understand that. And it seems like in the social media age, it's hitting kids younger and younger and hurting them more and more to understand that. I'm also a firm believer in the term normal exists. I'm very against people who say there's no such thing as normal. I think there's a bunch of people who have seen a normal distribution listening to this podcast before. There is such thing as a normal distribution. Go look at a sorority party at a college campus and look how everybody's dressed. Everybody there's a normal distribution, and then to have normal, you need the outliers. And so what I think the issue is that we assign good and bad to where you are on that spectrum. And therein lies the issue. And what I think I've come to learn is there's nothing wrong with being on the outliers of that normal curve. It just is different, and different is scary, and different is treated badly by people. You know, kids are mean to each other, and society doesn't understand, but that doesn't mean it's not the way it is. And so I think for me, it's kidding myself to, you know, trust me, there's plenty of times that I envy. I have friends who work jobs, you know, work labor jobs, and I love digging holes and fixing things. And, you know, some of the best times of my life were working, driving my work truck around in the summers, fixing houses and stuff. I'd work 8 to 5, I'd go home and I'd be done. And every minute after that, I was free. And I really enjoyed that. But I didn't enjoy it in the sense that it was not who I really was and couldn't engage me 24/7 for my life. So for me, it really, being an entrepreneur is who I always been, or what I've always been, and who I'm going to continue to be. But I've come to realize that people don't understand this life. And even I think for, you know, academics, oh, you teach 2 classes, what do you do with the rest of your time? And they don't understand the trials and tribulations of being a tenure track faculty. But that's reality. Nobody understands. And so tough. I think it's really, if you have the itch, scratch it.
Yeah.
I think that's a big thing. I think positioning oneself to have the ultimate flexibility in what you do. My PhD advisor, John Oakes, who was really involved in education, and I owe a great deal to his, you know, willingness to you know, mentor me and think outside the box. He said, you know, graduate school is the last time in your life you will have a single track mind focus. And it's true. And a funny story, you know, while I was writing my dissertation, I also became faculty, teaching 3 classes, not sleeping. And my first day of lecture, and I'm pretty good with technology, I show up and the technology isn't working. I can't get the stupid thing to put it on the screen. And I was just like, this is every stereotype of, you know, the professor, papers flying everywhere, chalk on their hands and on their shirt. And it was like, what I realized was, it's not that they're inherently, well, you know, there's always kooky people everywhere, but it's more that there's just so much going on that you're pulled in a million directions. And so something's got to give out of all of that. So, you know, I think it's a weird existence, but I wouldn't trade it for anything. I think it's knowing what you want to do. I've been very fortunate in my life that I've gotten to try a lot of things on. I got to try on being a faculty member, go to faculty meetings, see if it was for me. I think for graduate students, it's really important to try to at least TA. If not, see if you can go, and there's different levels of TA. There's TAs who grade homework, and there's TAs who run the lab section by themselves. And I think it's really important to try, if you think you're going to want to be a professor, odds are you're going to have to teach at least 1 class until you write enough papers that you become so important that you can do what you want. So try it on, see how it feels. Make sure that's for you, because there's plenty of opportunities to do it. And I think, remember that once you're in the program, you do have to stand up for yourself a little bit. My joke always was, the easiest way to graduate your PhD program is get a job, and then you'll graduate, you know. But think about it. That means that you do have some power in this relationship, right? You're the one taking ownership. So I think, you know, there is, it's kind of like the opposite of universal basic income in grad school, where, you know, your funding is tied to your work. Similarly, like, well, if you separate the two, which is, you know, our earlier conversation, but at the same time, you need to learn to stand up for yourself a little bit and really work to drive your ship. And what's the worst case? They say no. Once they're invested in you for 2 years, you think they're going to fire you on the spot? No, they have to have a conversation with you, because it's too expensive to get rid of you. So you do need to have a little bit of self-respect. Again, don't tell, you don't curse out your, but I think you're on this ride too. And the most successful graduate students and the most successful people I know are those who are working on things they're passionate about and have a stake in their futures. And there, I forget which book it was, maybe a Malcolm Gladwell, where they're talking about people in retirement homes. And those who live the longest in the retirement homes are those who take ownership of their own destinies. Whether it's they have everybody's got the same meal and they trade different food items just to have what they wanted for lunch, or they rip the furniture off the wall and rearrange it in their room just to have some semblance of control of their own destiny. Studies have shown that those people live longer in those homes. And I think the same thing could probably be distilled down to your graduate experience of, if something's really important to you, you need to drive for it because it's your experience. And if your advisor is not, putting your best interests in line, you got to really ask yourself, what's going on here?
Mm, That's yeah, very very excellent point. Thank you, Matt, for that.
You're welcome.
So we're closing to end. I have a few questions. The first one: what is your aspiration for Flex Robotics? What's something you every day I want to reach this level? What's your aspiration?
My vision is someday to walk into a Home Depot or Lowe's and see a FlexBot on that shelf would be pretty cool. That would be. But right now, it's getting these first links out the door, and I think the first huge milestone is going to be just going out in the field with somebody and them showing me the problem they have, and holding that FlexBot and solving their problem and seeing that smile on their face. Having been working on this technology for a lot of years, last night I was watching Mark Roper on YouTube. Was doing a video about the new rover that's about to land. I think it's today's the 17th. I think tomorrow's landing day. And he was showing the footage from whatever it was, 7-8 years ago when he was working on the first one. And to see the excitement in those folks when that rover touched down. And it really resonated with me because I'm like at that stage where they were in the clean room packing it up to go in the rocket. That's where we're at with this. And so I think, just having that move and being able to do something with it, I'm really excited.
I can feel that.
There's going to be a bottle of champagne then,
I can feel that. Yeah. And what could be the most important quality you have gained so far, and you have to maintain?
The most important quality I have gained. I think I've learned a lot of business. And that's critical because I'm running a business. And business is what allows me to do technology, not the opposite. And what good is all of my tech if nobody wants to buy it? Frankly, it's the same thing with research. What good is your research if nobody wants to fund it?
Yeah.
And I don't think it's the research. I think it's how you're selling the research. Same thing. It's not the FlexBot. It's been how we talk about it and how we convey it. So very clear messaging is critical. So I think learning, and frankly, I learn new stuff every day. And that's my favorite part of this is every day I wake up and it's something new. And it's some new legal document I get to learn about, or I got to set up payroll this year and learn about how you do that and all this stuff. And so it's becoming truly interdisciplinary, and really I love learning by doing, and getting a real life MBA by just building a startup has been phenomenal. And then just meeting people and having conversations and the ebbs and the flows and building a team and starting to have people who, when I'm having a bad day, I call them and they go, this is, remember that conversation? And when we're having a good day, it's people to celebrate with. So I think those are a few of the big things.
Yeah, great. That's a really also good point. Yeah. And do you think ego is important for you sometimes in discussion or proposing new ideas? Do you think ego sometimes is important to you since you're in this kind of businesses?
My ego?
Yeah. Do you think it's important for you?
I think it takes a balance. It's kind of like speaking softly and carrying a big stick. You know,
Mm.
that notion of I'm on the call to learn from somebody else. And I think something I do very well, having worked careers from, you know, mechatronic consulting down to taking people whitewater rafting and washing their wetsuits afterwards and unclogging toilets, and working with the people who do that, it's learning that, am I any better than them? What is intelligence? And what's, you know, stupidity? Well, stupidity's got nothing to do with intelligence. It's everything to do with your actions. I know smart, stupid people, and I know stupid, smart people. You know, like
That's interesting.
or you know,
Yeah.
it goes full circle there.
Yeah.
And so I think it's really important that I try very hard to recognize everybody's awesomeness in what they do. You know, they can quite literally be the world's best poop shoveler at the farm, you know,
Yeah.
but they are the best at what they do. And there's something that they can teach me. And it doesn't matter that I know more calculus than they know how to smell or spell. What does that have to do with shoveling? Right. And so I think checking the ego has been very important, and connecting with people on a level that what makes me better than them? I'm not. I'm different. And I think that's
Mm.
really
That's also excellent. Yeah. And lastly, what was the best advice was given to you? And maybe it was life changing advice.
the best advice. Hmm. When I was 16, my mom told me about a rule on our way to my driver's test that got me my permit, but I don't think that's the answer to the question you're looking for. Um,
Anyway, yeah.
I'm thinking of the best singular advice. There's been good pieces of advice. I mean, I think one of the best pieces of advice was that everybody's going to give you advice, and you need
Mm.
to take a step back, and you need to put a low pass filter on it. You need to dampen it out, because if you treat every piece of advice like marching orders, you're going to zigzag back and forth horizontally and get nowhere closer to your goal. So you need to take it all in, but you need to drive your life. So you got to take the advice from everybody, synthesize it, and then make your own decision based on it.
Mm-hmm.
Because mentor whiplash is a huge thing. And I've been on things where you have one call in the morning and you make up your mind, and then you have a second call with a different mentor and they're like, no, don't do that. And then, you know, you're back, forth, as opposed to can we,
Yeah.
you know, filter it and go smooth.
That's also important. Yeah. Thank you for sharing that. And do you have any final words to robotics community would like to say? Any final words you would like to say?
Yeah, I mean, I think I'm really excited to see what comes next. And I
Mm.
think there's great opportunities for us to all work together. I think for the students, as somebody, you know, we've been trying to hire a roboticist, what I really encourage is taking one step outside of the classroom and beyond your, you know, building a portfolio, showing us what you've worked on, pet projects, things like that. Because also some of the coolest things, look at the companies like Google who give people, you know, 10, 20% of time to work on pet projects to create great things. So I think it's really important to, even if nothing else, just to stand out, to work on something for fun that shows off what you did and learn and really show what you've been working on, because I think from there, we're going to see some really cool things. And I know for us, that goes a long way when we're trying to figure out, you know, who we want to bring on and what they're going to be able to do.
Mm-hmm. So thanks a lot, Meta. Thank you. Very inspiring and also hardworking person and intelligent. So thanks a lot for sharing your experiences with us. And yeah, it's a honor to have you. Thanks a lot. Thank
Pleasure,
you.
Marwa. Appreciate it.
Thank you.
Take care.
So